In this video, I'll be solving the 15th problem of AIME-2 2020. Let ABC be an acute scalene triangle with circumcircle omega and tangents to omega at B and C intersect at T. Let x and y be the projections of T onto lines AB and AC. Suppose BT is equals to CT is equals to 16, BC is 22, and TX square plus TY square plus XY square is 1143. We need to find like what is XY square. So if we consider a circle, so we are having a acute angle triangle ABC, and the circle is omega. So let's say, and like we're also having the tangents. Let's say the tangents are there from T. So since they are intersecting at T, so we're having like tangents, something like this. So this is T, and we have like the projections of like AC, sorry, like from T, like we're having the projections being like this. So this is Ty and Tx. Now like we're having, let's say if S is the circumcenter. So I'm considering S is the circumcenter of this circle omega. So that means we can notice that like this triangles, the triangles SCT and SBT, like they are same, like congruent triangles. And suppose if I consider this midpoint as some M, so that means, so we were given that BT is 16, so BT is given as 16, and CT is also 16, so and BC is, so that means if we draw to midpoint, this will be perpendicular, even this will also be perpendicular, and we're having like BC is 22, so that means this will be 11 and this will be 11. So that means we can find like the MT's length. So MT's length is nothing but square root of 16 square minus 11 square, which is 256 minus 121, which is square root of 135, that is nothing but 3 root 15. Now if I consider like angle A as some alpha, angle B as some beta, and angle C as some gamma, so that means this is alpha, and similarly we are having this entire thing as beta and this entire thing as gamma. Now that means like if that is alpha, this will be 2 alpha, so that means this will be alpha and this will be alpha, because if you are having a circle, so and if you are having, so if this is making an angle theta, this will make an angle 2 theta at the center of the circle. So that means if I take angle BSC, so BSC will be 2 alpha, so that means STC will be 90 minus alpha, because this is a tangent, so this will be 90 minus alpha. So this will also be 90 minus alpha. So that means angle CBT, if we consider, so this CBT will be again alpha. So CBT is equals to BCT is equals to alpha. Now basically in this triangle, we are having like CBT. So we're having like cos alpha. So cos alpha is nothing but BM divided by BT, which is nothing but 11 by 16. So cos alpha we are having 11 by 16. So if we take this diagram, so we can also observe few other things. So now if we consider, let's say this quadrilateral like AXTY, so the quadrilateral AXTY is nothing but a cyclic quadrilateral, because we're having this as 90 degrees and this as 90 degrees. So we have like AXT is 90 degrees and we also have AYT being 90 degrees. So that means I can say AXTY is a cyclic quadrilateral. Now if this is a cyclic quadrilateral, angle XTY will be nothing but 180 minus alpha. So similarly, if we also consider this BMYT or like BXTM, and sorry, like here like X and this is Y. So this is X and this is Y, because the projections of AB is X, the projection onto AB is X, and the projection onto AC is given as Y. So that means like if we take like BXTM and CYTM. So these are cyclic quadrilaterals. So now like if these are cyclic quadrilaterals, if I consider like the midpoints, suppose let P and Q be the midpoints of this BT and CT respectively. So that means like this is P. So this point is P and this point is Q. So we can say that P is center of the circumcircle of quadrilateral BXTM, and Q is center of circumcircle of quadrilateral CYTM. So that means if we consider like, so basically these two are like cyclic quadrilaterals, and even this big one, this is also like one more cyclic quadrilateral. So that means like if we now consider like triangle BXTM, so in like BXTM, we can notice that angle like MBX, so this total angle, so that is nothing but angle MBT plus angle TBX, like this angle plus this angle being like MBX and MBT and TBX. So MBT is nothing but alpha, and TBX, so TBX is nothing but 180 minus alpha minus beta, because we consider this as beta and this as gamma, like alpha, beta and gamma as the angles of this triangle. So that means by using that simple angle chasing, like we're getting this as 180 minus beta. And if we see like we are having straight line there, so beta plus alpha plus angle TBX is 180 degrees. So that is the reason why I directly wrote this thing as 180 degrees minus beta minus alpha. And now like since it's a cyclic quadrilateral, angle like MBX plus angle MTX, sum of opposite angles in this quadrilateral should be 180 degrees. So that means angle MTX is nothing but 180 degrees minus 180 degrees minus beta, which is nothing but beta. So in a similar way, we can also see, suppose if angle YTM, so if we consider angle YTM, so YTM if I consider it as gamma, so that is nothing but 180 minus alpha minus beta. So YTC will be 90 minus beta, so that means angle YCT will be beta. So YCT will be beta, and this will be 90 minus beta. So now, so we are having like this. So let me again take this diagram. So this is X and this is Y. And this is P, and this we took it as Q. So if we consider this angle MTX, so we just now got like angle MTX, so beta, which is angle ABC, so that is also this angle MTX. So that means like this entire angle is also beta, and this entire angle we got it as gamma. So if I write like MTX is nothing but ABC, and gamma similarly we got it as ACB, sorry, we got it as like YTM. So that means like if we just consider this BXMT, so we are having like if I just consider this particular circle BXTM, so we are having like angles in the following manner. So we have like B here and X here, M here and T here. So we are having like something like this. So we have like point P will be the center of this circumcircle. So this we have it as beta, and this is also we have it as beta, because this MTX is beta, so therefore it will split it into two betas, like if we join this MX as well. So angle MTX is beta, I can say that angle MPX will also be 2 times beta. So if I use like sine beta here, so sine beta in this particular triangle is nothing but opposite by hypotenuse, opposite side is nothing but xm divided by 2 whole divided by, it will be xp. So that means xm is equals to 2 times xp sine beta, and 2 times xp is nothing but bt, so that is nothing but bt sine beta, and that is nothing but ct sine beta. So from this, like, we can say that xm is nothing but yt. So similarly, we can also say that ym is equals to xt. So therefore, like, if we use like Ptolemy's theorem in this setup, so we have cytm and even this bxtm. So they both are cyclic quadrilaterals. So if they are cyclic quadrilaterals, I can use like mb times xt. So sum of opposite pairs of sides is equals to product of diagonals. This is by Ptolemy's theorem. So by Ptolemy's theorem, we have mb times xt is equals to bx times mt, which is nothing but mx times bt. And so that means like bm, we already know it is 11 earlier. So bm is given as 11. And since bm is 11, so xt is, I can take as xt, and mt also we found as 3 root 15 times this bx is equals to, now since we got like mx is nothing but yt, so I'm writing it as yt into this bt is nothing but 16, because like we know that this is bt is 16, this is 11, and the mt, so this mt is nothing but 3 root 15. So that means similarly we can also write for like the other quadrilateral, like cytm. So for cytm, like we can write 16 times tx is equals to 11 times ty plus 3 root 15 times cy. And we also have, like, if we take this triangles, so bxt is a right angle triangle and cyt is also a right angle triangle. So from this we also have bx square plus xt square is 16 square, and cy square plus yt square is also 16 square. So we have these two equations, we also have these two set of equations. And apart from that, if we just consider the triangle xty, this triangle, so xty triangle is something like this. So we are given x, y and t. So this is like 180 minus alpha. So that means cos of 180 minus alpha, we already know that cos alpha is like 11 by 16. So that is tx square plus ty square minus xy square by 2 times tx times ty. So that means cos 180 minus alpha, from allied angles it is minus cos alpha. So that means it is minus 11 by 16 tx square plus ty square minus xy square whole divided by 2 times tx into ty. So that means tx square plus ty square plus xy square minus 2 times xy square is nothing but minus 11 by 8 xt times yt. But we already know what is tx square plus ty square plus xy square. Since we are having this, like, we are using cosine rule so that we can get similar type of terms. So that means like this is nothing but 1143 minus 2 times xy square is minus 11 by 8 xt times yt. So that means 2 times xy square is 1143 plus 11 by 8 times xt times yt. Now, like, we have like several equations to work with. So if I write like all those equations here once again, so we have 11 times tx, these two equations, and this equation. We have already used this information, so that's why I'm not explicitly writing this equation. Otherwise, like, we also have that equation. So 11 times tx plus 3 root 15 times bx is 16 times ty, and similarly 11 times ty plus 3 root 15 times cy is 16 times tx. And we have like bx square plus xy square is 16 square, and cy square plus yt square is 16 square. And we also have 2 times xy square is equals to 1143 plus 11 by 8 xt times yt. So that means this equation is nothing but So it's just like algebraic manipulation now. We just need to find like what is the value of xy by using all these equations. So 16 times ty minus 11 times tx, it is nothing but minus 3 root 15 bx, and this is nothing but 16 times tx minus 11 times ty, so that is 3 root 15 cy. So if I square on both sides, I'll get 256 ty square plus 121 tx square minus 2 into 16 into 11 into tx into ty is equals to 135 bx square. In the similar way, 256 tx square plus 121 ty square minus 2 into 16 into 11 into tx into ty is equals to 135 cy square. So if I add these two equations, so 377 into tx square plus ty square minus 4 into 16 into 11 into tx into ty is equals to 135 into bx square plus cy square. Now we already know what is bx square plus cy square. So that is nothing but 135 into, so if I send them to the other side, like that is 16 square minus tx square minus plus 16 square minus ty square. So that means this entire equation, so 377 into tx square plus ty square minus 4 into 16 into 11 into tx into ty is nothing but 135 into 512 minus 135 into tx square plus ty square. So if I take it to the other side, like I have like 512 times tx square plus ty square is nothing but 135 into 512 plus 4 into 16 into 11 into tx into ty. So that means tx square plus ty square is nothing but 135 plus, so 64 divided by 512, which is nothing but 8, so tx into ty. So that means tx square plus ty square, we already know what is tx square plus ty square from this. So we have like 138 plus this thing, so that means like here 11 by 8 times xt times yt is nothing but 2 times xy square minus 1143. So if I use this thing over here, so that means 2 times xy square minus 1143 is equals to 135 plus so 11 by 8 times tx plus ty is what we are using. So we have like first thing is xy square minus 1143, or like 1143 minus xy square, because like we have like sum of these squares as 1143, so that is equals to 135 plus 2xy square minus 1143. So that means we have like 3 times xy square is equals to, because like here, like from this step to this step I am using tx square plus ty square plus xy square being like 1143. So if I use that here, so I will be getting 3 times xy square is equals to 1143 plus 1143 minus 135. So that means 3 times xy square is 2286 minus 135. So that means xy square is 2151 divided by 3, which is nothing but 717. So therefore the answer for this question would be 717. So that's it for this video. We'll meet in the next video.